Hey everyone, welcome back to the channel, and this time we are going to solve the problem array division. And in this problem we need to divide an array into k subarrays such that the maximum sum of any subarray is minimized. So for instance, let's say n is 6, so we're going to have 6 numbers, and k is 3, so that means we need to divide it into 3 subarrays. So let's say we have this array and we need to divide into 3 subarrays such that any this subarray has the minimum sum possible. So let's say, for example, we did it and we divided it into such manner. So this is one possible combination. I'm just writing it randomly. So this is a valid combination, right? Has been divided into subarrays, but is it minimum? Is it minimum? So here the max sum is 2 plus 5 plus 8 is 15. So this we are getting 15. Let's say if there is any other possibility. So let's say this time we divide this in like this: 9 comma 2, 5 comma 8, and 6 comma 3. Here the max sum is 5 plus 8, which is 13, which is less than 15, right? So this is a valid combination and this is a correct combination because this has the maximum sum which is minimized. Now you do any other possibility, it is not going to give minimum less than this. So there are various approaches which comes to us, and then the first would be like we need to take some decision based on whether to pick this number and put or not. So kind of a tree we can form, and that can be solved recursively, but that is not a good approach, I would say, because there is one better approach which solve it in much less work, and on top of that it is little bit difficult to think about it. So let's develop this intuitively how we are going to get it. So let's say we have this array. Now there are some two question I'm going to ask. First is, what can be the maximum sum a partition can hold? So in other words, if we have done the partition, we have divided it, what is the maximum sum it can hold? And the second question is, what can be the largest maximum sum a partition can hold? So this is quite two statement. Pause the video and think about it. The first is, what can be the maximum sum a partition can hold? So suppose some partition I have done, some random partition. So what can be the maximum sum? I'm not talking about the total sum. What can be the maximum sum which individual partition can hold? So that would be the largest of this array is this is the maximum sum. You can't go below this, right? So I have done a partition which consists of a single value, so this would be the largest value possible. And what can be the largest maximum sum? The largest maximum sum would be, instead of doing it in like multiple partition, I have done it in a single partition, let's say. So that would be a total sum, right, of this total would be this accumulation would be the largest maximum sum partition. That is total. That is like if I have 7, okay, divided into one partition, so you are going to take this and that would be the maximum. So in this case we have 9 and oh, so this is a kind of typo, I guess. So right would be not 9 but the total sum, right? 9 plus 2 plus 5 plus 8 plus 6 plus 3 is equal to 30. So our answer is going to lie between these two values only, right? You can't exceed. If there is a single partition I've said to do, you are going to take this complete array and put in that single partition, this whole thing. That would be maximum sum it can. And what the minimum would be? The minimum would be the single partition you have done, or not single partition, multiple partition have done, and you have put a single value in this, and that single value, that maximum would be the maximum present in this array. So this is kind of our boundary, and we know that this boundary is now going to be monotonic, right? Your answer is going to lie between 9 and 33. So somewhere over here, you can't go below this, you can't go up here. So now you have to find the sweet spot where you are going to do the partition, and that is going to give you the perfect result. So if I calculate the mid of this, so 9 plus 33 divided by 2 is 21. Now we have partition coming as given as 3, so I can put some values over here, some values over here, and some values over here. This mid 21 says that basically these anyone won't exceed 21. The max sum these numbers will hold will be 21. But is that a valid solution? Of course, it is a valid solution, and that will be depend upon our splitting possible or not. So you have said that the maximum sum subarray can hold is 21. Now the next question arises: can you do it in three partitions? Since question demands k as 3, you have to do 3 partition. So can you do this in 3 partition or not? If it is possible, yes, that is your valid answer. And now try to look below, minimize this basically. But if splitting is not possible, then you don't have to. Then you do, this is not a good combination. You have to increase, you have to increase your bar. So here we have to divide this in 3, and we are going to do a splitting possible. The ranges and division is similar to binary. The condition to check the splitting possible will depend upon something. So basically we are going to loop through the array, and we are going to create the total sum at each point. We are going to loop through the array complete, and at each point we are going to calculate the total sum. And then at each point here we are going to ask if total sum exceeds the mid value. That means exceeds the mid value. That means a subarray is possible, because you are able to find that sweet spot which is greater. So kind of let me take an example maybe to do that. So basically let's say we have 9 2 5 8 6 3. So you are doing the total sum and you are checking, okay, it is greater or not. So in first 9 9 plus 2 is 11. 11 is greater than 21. So that means you can create a subarray. So you are going to increase this total sum count. So 9 plus 2 plus 5, let's say you put 8. So this would give you 24. 24 is greater than 21, right? Now that means you need to so this means that in a single block you have put too much numbers, which is causing the mid value to increase. That means you have to increase the subarray. You have to create one more subarray, and before that you need to check the subarray count. If it exceeds the k, then you say written possible, splitting is not possible. So while coding this is much easy to understand while coding. So when I will be doing the program of this, then it will be very much clear to understand what exactly is happening. So let's directly jump into the coding, and we'll try to understand even more this portion. So n and k are there, and then I have input this in a vector or array, and then I'm calling an array division, which is going to give us the result, the minimum sum possible. So in this, first of all, we need to have the left limit with us. So that left limit is what? It was just the max element. So I'm going to have that max element with us. Then what was the right limit? Right limit was the accumulation. So I will have the accumulation of this, and then what we are going to do is we are going to have, and since we are playing with the long, let's pass this also. And now the old binary code, while left is less than equal to r, then our first job is to calculate the mid, and you can have the direct one, or you can have this little optimized. You can put the direct one also, which is like right plus left divided by 2. And now I'm going to call this function if splitting possible or not. So it is going to have the number, the amount of subarray you want, and the sweet spot where you are saying that, okay, this is my minimum. So if this is the case, then splitting is possible. Then this is one of our answer, right? So let me have a result variable, and in the beginning it is the max 33, right? The total single split. So I will have the mid here, and then if you are able to split over here, then decrease the right by -1. So here in that example 21, we were able to do it in 21. Let's try it for 20. Let's try for 19, like that. And if you are unable to do it, then increase. Maybe your sweet spot is little less to accumulate. So we are unable to basically split it. So that's why. And then at the end we can have the written result with. Now the main thing, how we are going to do the splitting. So let's try to understand it here over. So first of all, we will have the current sum with us. as told, we are going to loop over and calculate, and then we are going to have the sub array count, which is 1. You Why 1? Because one partition you are going to always do, right? There can be a 0, right? 0 partition, how is that even possible? Then I'm going to loop over the our numbers array. Then here we need to ask some couple of questions. First of all, total. What is total? Total is your current sum plus num. At any given, if total exceeds the max sum, which is your pseudo spot, right? If it has increased, that means in previous example we were doing 9 plus what was the number, 2 plus 5 plus 8. On putting 8, it was becoming 24. 24 was greater than 21. Is it greater? Yes. So that means we need to have another array to hold this, another partition basically, and our current sum would now be that number, because we have to start from that new number which we have, which we got, which increased basically the count. And here is a simple check. If subarray count is greater than k, that means you can't make now, you can't make a partition now. Why you can't make a partition? Because your subarray count is getting too much. 3 was given, for example, and you are now creating it 4 5. We haven't your, so that is not possible. And if total is not exceeding the maximum, so in that case what we need to do, if total is not exceeding the maximum, so we need to keep on adding, right? We need to keep on adding. So this we need to do. Let's try to understand this with an example. So in this case, let me take as 9 2 5 8 6 3. So left was 9, right was 33, the pseudo spot number 21, which is the maximum which I'm saying I can afford. So the total would be current sum, which is 9, which is 0 plus 9, right? In the first iteration, this is first iteration. So the total is 9, and is it greater than 21? No. That means keep on adding. So we are going to keep on adding, and then let's here we hit over this here. So 9 plus 2 plus 5 plus 8 is 24. So 24, is it greater than 21? Yes, it is greater. Then what we do, if it is greater, 24 is greater than 20, then that means I have to increase our subarray count, which was previously 1 to 2. Okay, this is, we can understand. Now we have to start from this number. We have to create our subarray from this. So the current sum would become 8, right? Because we have to start from this number. And is 2 greater than k? Is 2 greater than k? 2 is greater than 3? No, false. So this is going to be okay, and like this we are going to go again. Now this thing is going to happen again. I hope it is clear now. Let's try to submit this. So array division submit. Okay, so we are getting some bunch of errors. Okay, let's try to see what we have missing. Oh, over here we have to have the return as true. That means saying that splitting is possible. Let's try to again do the submit. Okay, it has been accepted.